You have a alkyl halide, you have a reagent, you got to analyze each side. This alkyl halide, you got the bromine on the primary carbon. That's something you can easily see here. So, and then you got reagent, ammonia, and also something called the DMF. But DMF, I just mentioned it in the previous slides, this is solvent. This is dimethylphoramine. That's a polar apropi solvents. So this is not the one that participates in the reaction. What is doing the reaction is ammonia. Ammonia is a base. I'm not saying it's not a strong base. It's a kind of moderate base. It's a moderate nucleophile. So it may be acting possibly for the SN2, possibly for the E2. But we have a substrate, alkyl halide. It's a primary alkyl halide. So this is where the alkyl halide can narrow things down to choices. SN2 reactions, that's the thinner the better. The primary is the best for the SN2. Secondary is kind of a stick and go, but crucially is narrow. E2 elimination reactions, more substituted the better, because it makes a more substituted double bonds. So that's the most stable products. So tertiary alkyl halide makes the E2 elimination go faster than secondary and then primary. So since this one is a moderate base, moderate nucleophile, we cannot make a choice based on this, but we can make a choice based on this. That's a primary alkyl halide with a moderate base and nucleophile. I would say that this will probably go for the number 2 out of each, because that is a primary alkyl halide. So that's the thing. It will make an attack, kick it out. We got the SN2 reactions. Some of you may think that, oh yeah, this proton will be picked up by the base and you get a double bonds form. Yeah, sure, it's possible, but that's going to be really, really minor products. Because these are primary alkyl halide, not a really good substrate for the E2 elimination. So this, I don't think that is something that you should consider. And then this halogen popping out make a carbocation even more absurd, because this reagent is strong enough to get this thing done. It's not waiting. It's not waiting until the halogen pops out. So it's already doing something. It's SN2. So this process, carbocation formation, not even happening. And also, this is a primary alkyl halide. Primary carbocation is the worst one. So it will be even more slower. So SN1E1, not going to happen. So you have to make a choices based on what you see, and you got to reason it out to find out what would happen most likely. Next question, you got alkyl halide, but this chlorine sitting on the tertiary position. So this is a tertiary alkyl halide. You got the pair of the reagents, the dark side in methanol. Okay, when you have a strong reagent, there's a weak reagent present together, this is not going to have a chance to do anything. This will get the job done first. It's a tertiary alkyl halide, so how you can imagine that being as a nucleophile, making a attack, kick the chlorines out, is not a good idea, right? Because the tertiary alkyl halide SN2 reactions are really, really not going. I haven't seen them yet. So this is not going, not because this is nucleophile, but this is tertiary alkyl halide. So then this one acting as a strong base, and then it can possibly have two different protons in adjacent carbon. If the base can pick this one up, you get the more substituted double bond made by the elimination reactions. If the base can pick up this one, you get another double bond forms. But this one's also tri-substituted double bond. So I guess both of them are same degree of substitution, tri-substituted double bonds. So I would say both will form similar amount, but why am I saying there's a major, not this one? I haven't given the reason for this one yet. If the double bonds are formed within the ring, it actually makes it more stable compared to the double bonds formed made outside of it. So that's something with the endocyclic double bond. This is an exocyclic double bond. Since I didn't talk about it, if you give both of them, I should probably take both as an extra. But now you know this was a major backwards minor for the reason we'll talk about it. Within the ring is a stable than what was outside. But one thing that you shouldn't do for this type of question, you form a carbocation because it's a tertiary halide. Yeah, that may lead and make a carbocation possible. If you don't have this methoxide, then this is what happens. But having the methoxide solution basically make that process not happening. It's not waiting. This will take time. That guy's impatient. It's not waiting until the carbocation forms. So this is an E1 process, E2 process, SN1 process. Could happen if you don't have the strong medium like this, but since it's there, it's not happening. So you have to figure things out. I'm not saying that SN1 E1s are not happening. That the only that can happen only there's no strong mediums.